Hello guys, today we're covering 10 math problems based on invariance, okay? Invariance. I've uploaded this already, but I found out that the audio was not quite clear, so redoing this concept. So let's just start it up. An 8 into 8 chessboard has opposite corners removed. Can you cover all 62 remaining squares using domino tiles? Each covers 2 squares. Okay, so now this is a very simple question. They said opposite corners are removed, right? So two white corners are removed, or else two black corners are removed. So we have either two white lost and zero black lost, or else two black lost and zero white lost. So there's always a color imbalance. If you take two squares, one is white and one is black, but the color is imbalanced. So with balanced colors, that is the alternative colors, you can't quite fill it up. So that's it for this question. So let's just go to the next question. Start with numbers one, 2, 3 up to. Oh, come on. Sorry, just a minute. Okay. So start with numbers from 1, 2, 3 up to 4 and minus 1. Pick any two numbers, replace them with their difference. Repeat until one number is left. Prove it's always even. Okay. First of all, what is the formula for sum of first n numbers? Okay. I recommend you maintaining a small note for IMO, not for being orthodox and so bookish, doing many formulas, but to know what are the exact only formulas that are absolutely needed in IMO. So the formula for the first, the sum of first n numbers is n into n plus 1 by 2. So here is 4n minus 1 into 4n minus 1 plus 1 by 2. So minus 1 plus 1 cancels, so 4n minus 1 into 4n by 2 is equal to 4n minus 1 into 2n, which is always even. And when you for example, let's say you take 3 and 1, you subtract 3 minus 1, which is 2. 3 plus 1 is 4. 4 minus 2 is 2. So we're only reducing the whole sequence by an even number, by always an even number. That's what says here. So this is just minus a minus b plus a minus b. It's minus 2b. This is a bit too theoretical, so you can I don't recommend you worry a lot about that. Just do one thing. Take an example. 2 minus 1, that's 1. 2 plus 1 is 3. So 3 minus 1 is 2. So it's reduced by an even number. So the sum is still always even with one number left. That's why the answer is always even. So the next question. All coins to show tails. Each move is flipped exactly 3 coins. Can you reach a state with exactly one head? Okay. Uh, this is quite impossible to do. That's why we're going to use our key inside our weapon. When we're not able to reach it, it's an impossible problem where you use this one. Plus or minus 1. That's it. Now, plus or minus 1 is for flipping 1 coin, but you're flipping 3 coins, so you take plus or minus 3. So you initially start with 0 heads and then 3 heads, and then again 3 plus 3 is 6, right? 3 plus 3 is 6. Yes, but we don't do that. We go 2 moves. If you flip 3, then flip 2 of those back to 1 head, right? So what I'm trying to say is we already have 3 heads. If you try to increase it by 3, for example, let's say, we it would be subtracted by 2. So that's only see, this is exactly what I'm trying to say. Okay, let's just rethink a lot about this problem. This plus or minus 3, let's keep it in mind. Flip 3 coins once, okay? You'll get 3 heads, and then flip two of those back, and you'll only get 1 head, right? So this is definitely possible. Flip 3 first, and then you can flip 2 back to get 1 head. So that's quite simple. Okay, you have the numbers 1 to n in some order. You can only swap two numbers that are next to each other. Prove that each swap changes whether the total of order out of order pairs are even. Okay. Wait a minute. Let me explain this to you. Let's say we have 1, 2, 3, and 4. Okay, just write it down. just to visualize it, okay? I'm also writing it down here. We have four numbers, 1, 2, 3, and 4. Let's swap 2 and 3. 1, 3, 2, and 4. The number, first of all, in the first one, the number of swap is 0, and the number of out of order pairs is also 0. Here, the number of number of swaps is 1 after swapping 2 and 3. Now the number of out of order is 2, right? 3 and 2 are out of order. So let's again swap it 3, comma 1, comma 2, comma 4. We're flipping 3 and 1. So now how many out of order pair are there? 3 out of order pair, right? So every neighbor swap changes the count of order pair exactly by 1. So odd or even always flip. If you see the first one is 0, then first one we didn't start the step yet. That's why it's increasing by 2 steps. So we shouldn't confuse with that. We should start from the first step. After swapping the first one, then only we can conclude to exactly 1. So the first step is 1, 3, 2, 4 with 2 out of order pairs. I mean, actually it's 1 out of order pair. It's a pair, not numbers. So 1 out of order pair. And then here it's the next one it's 2. Let's take 3 and 1 and 1 and 2. They're out of order pairs, right? 3 and 1 are displaced and 1 and 2 are displaced. So 2 out of order pair. So 0 out of order, 1 out of order, and 2 out of order. So that's why this one comes. Every neighboring swap changes count of order pairs exactly to 1. So odd or even always flips. Uh, okay, in the sliding 15 puzzle, prove that you can't reach every possible arrangement starting from the solved state. Okay, that you obviously can because you completely change the permutation parity. When you have 15 numbers and one blank place, even you slide it to the blank space. One of the numbers to the blank space. You completely change the property of the puzzle, so you can't come back and that's it, right? Okay, stand on grid. Each step you move on one square. Okay, move one square up, down, left, to right. Prove you can't return the starting square in an odd number of 10. Okay, let's say you go one step. The minimum number of steps to get back is 1. Let's say you go 2 steps. Minimum number of steps you come back is 2. You can also come in you can also come in 4 steps. I'm just imagining a chessboard. Uh, but you always end up having the even, you know. You can never end with odd number of steps. You go in, you come back. When you go in with odd steps, you come back with odd steps, and when you go in with even number of steps, you come up with even number of steps again. So you can't quite end it with odd number of steps finally. Okay, okay. A and B. So we're just taking 2 examples. For A and B. Don't ask me why A is particularly equal to 48 and 18. There's no such reason. I'm just taking something that has a greatest common divisor other than 1. These two are not prime, right? So we can just take it. Apply the rule. Okay, we saw it in yesterday's concept. If you don't know this, you can see it in yesterday's concept. 48 minus 18. 18 comes here as it is. And 48 minus 18 is 30. And 18 comes here as it is. Again, 30 minus 12 is 18. You can also have 18 or 12 because 24, 30. You don't have to confuse much, okay? There's a simple step, okay? 48 and 18 first we have. And then just subtract 48 and 18, 30 and 18. And then subtract 18 and 30, which is 12, 18. And this is bigger, right? So you place the bigger one in the front. The bigger number should be on the left, okay? So 12 is quite here, and 18 minus 12 is 6, so it's in here. 12 minus 6 is 6 here, and again 6 just copied it down. 6 again. So the GCD is 6 throughout. Again, I'm saying GCD is nothing but the greatest common divisor. So that's it. That's just the greatest common divisor, right? So that's always 6. If you see the greatest common divisor of 48 and 18, you can only divide with 6. There's not much greater. You can't say 12 or 18 like that. You only say the greatest, greatest, greatest. That is okay. Do one thing instead. You can find the HCF instead of the GCD, because the GCD is equal to the HCF of the two numbers. So the HCF of 48 and 18 we found, and that's it. 6 to out. Keep having. Okay, this is a very simple kindergarten question. I don't know why this is asked at IMO level. Well, let's just do it. Take any positive integer, repeatedly replace it with greatest integer factor of n by 2, drop the remainder. Prove this always eventually reaches 0, okay? Drop the remainder. Okay, you know why? This is called the greatest integer factor, this symbol. It's called the greatest integer factor. Uh, you just swallow the remainder. I mean, for example, let's say 6.8. What is the most closest integer which is lesser than 6.8? 6, right? And if you take minus 1.8, we can quite say minus 1 because minus 1 is greater than minus 1.8. What is the integer closest to minus 1.8 that is lesser than minus 1.8? That is minus 2. And that's CIF, okay? So that's it. You can just go with it. So let's just take some examples. It always ends with 0. 6.5, gobble up the 0.5, and then 3, and then 1.5, gobble up the 0.5, and then 1, 0.5, gobble up the 0.5, again 0. Stop in 4 steps. And again, you take 100, eventually gets divided, it always stops. And that's it. You just take some examples when you're stuck. When you're completely stuck, you always take an example, and you're gonna get the answer. Even when you can't take examples, you can use the plus or minus one trick. That's really good. So in any network graph, okay, prove that the number of nodes so far. Okay, yesterday I taught you this guessing strategy. Okay, just a minute, just 1 minute. Sorry for the delay, guys. Okay, let's just again continue from the slide, and then I'll just take lasers. Just cool. So okay, this is what I taught you before. Uh, it's actually not completely a guessing technique, but well, when you're asked to prove such a question, you can just write down the formula. If you don't know the formula, go and check it out in my last video. The formula is given. Okay, you give any graph, the result always gets even. That always happens. Odd number of connections is always even, right? I'll also tell you one thing. One logic if you can't quite you know be satisfied with this. So let's say you take two roads or two people. Uh, they have only one connection, but if you take two people, there are people, two people, one connection, and two roads, one connection. You have it like that. So even the nodes are the number of roads and the number of people respectively. And even though if the number of connections are odd, you always get it as even. The number of nodes is even, right? So that's it with this question. There's not much to do with this question. Okay, now this is again a kindergarten level question. Starting from 0, you can either add 5 or subtract 3. Can you reach the number 1? Okay, let's start from 0, and first of all, add 5 because 1 is greater than 0. We have to add something, right? So let's just add 5. We get 5. 5 divided by 3 has a remainder of 2. So when you subtract 3 from 5, you only get a remainder. I mean, any number of steps you can subtract, but you'll still get it as 2. The final number will be 2. Whereas you can again start adding. 5 plus 5 is 10. So 10 divided by 3 has a remainder of 1. So eventually it will always end in 1. So that's it. Okay, you have 5 and then 5. So that's 10, right? Finally you have 10. 10 minus 3 is 7. 7 minus 3 is 4. And 4 minus 3 is 1. And that's it. You reach 1. So yes, you can always reach 1. So this is just a quick reference of all problems. Okay, now actually take a screenshot because it's too important. Even though I've provided 10 problems and I'm gonna upload some problems every day, uh, you still should practice more problems whenever you have time. So do exactly what I say. I have the best proof for this. First of all, take the screenshot of this. So after taking the screenshot, you can go to ChatGPT or Gemini or anything, and you can upload these. Give me IMO level questions for these concepts, for these type of concepts, and it'll give you. You can just practice those, and that's it for today, guys. Tomorrow I'll be re-uploading the video on the synopsis of Mod 2, Mod 3, Mod 4, Mod 8, and Mod 9, and those stuff. So today, that's all. Stay tuned for my math club link. When I complete this AI course myself, I'll be uploading it for you too. So after uploading, I'm gonna immediately start the channel. So I mean the club. So if you want to improve the future, stay tuned and join my club in the future. So that's it for today, guys. Bye. See you tomorrow.